Okay, thank you so much for inviting us to your event. Um, yeah, I'm just to shortly introduce myself. I am Jem, and I'm the team captain of this year's Delft Hyperloop team. And with me also are Olivier and Daan, a public relations manager and a propulsion engineer from our team. So to shortly just introduce our team, um, our team consists out of 40 ambitious students from the Delft University of Technology, and we're based at the TU Delft campus in a place called the Dream Hall. And yeah, our basically we're here with five other student teams working on innovative projects out of the TU Delft. And the mission of our team is to develop an innovative Hyperloop system to accelerate its full-scale implementation. And with this mission, every year we participate in the European Hyperloop Week, which this year will be in Zurich. And I was asked to tell maybe a bit more about the history of Delft Hyperloop and the legacy of our team before going into the technical part of our team. So yeah, Delft Hyperloop originated out of the SpaceX competition in Los Angeles about 7 years ago, and that's where Delft Hyperloop was first conceptualized and the team originated. And Delft Hyperloop became the first place contender in the SpaceX competition, and yeah, was inspired by Elon Musk's vision of the Hyperloop system. Yeah, after this, Delft Hyperloop continued with the SpaceX competition and got a speed record of 142 kilometers an hour. But this competition was really focused on the speed of systems and not necessarily the scalability of these systems. So Delft Hyperloop 03 was the first year when it became a dream team, and this was still focused on speed at this time. But after this, DHO 5 was the first team to compete in the EHW during the COVID time, and this competition was more focused on scalability and the scalability of a Hyperloop system to accelerate this full-scale implementation, which is really aligned with the goals of our team as well. And after this, DHO6 became the first, developed the first levitational system, a bidirectional Hyperloop, and placed first in the EHW with winning their complete pod design award. So looking back at all these years, we have here an overview of the Hyperloops that have been developed by Delft Hyperloop. So continuing on with last year's pod, and going a bit more into the technical aspects of what set our pod apart, basically. So yeah, these technical aspects were at first full levitation. So developed a fully levitational system for the Hyperloop, meaning no contact with the track whatsoever, and it's a hanging track. Apart from that, we developed a new kind of motor, an LSFPN motor. And along with these two, we integrated a thermal management system into our complete design. So full levitation. Yeah, as I said, full levitation meaning that the pod did not touch the track whatsoever at any point of our runs. Doing this with the HEMS and EMS systems. So for lateral levitation, we use the EMS systems, and for vertical levitation, we use the HEMS systems. And then going on to the new motor, if it works. Yes, the new motor. Yeah, so in the past, the focus of the motor and the competition was mainly into speed, and now focusing onto the scalability of the motor. So this also came along with a different kind of motor design, because while the first motors Delft Hyperloop developed had coils in the track, meaning that the pod was light, very simple, But obviously, having a coil all along the track means very high cost of your system, and it's also not that sustainable if you want to realize a network of Hyperloop throughout the continent, for example. So last year's team, they developed a new kind of motor, the LSFPM motor, which makes use of the motor being placed on the pod instead of on the track. So this is basically how it looks like in a schematic view. And this motor has very high efficiencies, is much more scalable than the earlier developed motors, and a much more sustainable solution because the track only consists out of steel and not any rare earth metals, for example. And apart from this, we have the thermal management system. And yeah, the thermal management system is obviously very important in a Hyperloop because a Hyperloop is used in a vacuum environment, which means it's very hard to cool your system because you're in a vacuum environment. So placing some systems that are not vacuum compatible inside a vacuum box on our pod means that we have to cool the system. But how can you cool a system if it's in a vacuum? So for this, we came up with the solution of designing a PCM, so a heat battery basically, and this heat is captured then in this heat battery by capturing the heat in candle wax, and yeah, basically charging the battery, let's say. Apart from these technical challenges we solve in our engineering departments, we also conduct full-scale research because a lot of problems arise when transforming a Hyperloop into a very big system. So we make a pod of about 2 to 3 meters long. Well, what happens if you make a pod of 40 meters long? And for this, we conduct full-scale research, which is all publicly available. And we do this on a technical level, but also on a non-technical level, so a socio-economic level. And last year's research entailed the community acceptance of a Hyperloop infrastructure. You can imagine this kind of project, or kind of, yeah, to realize this kind of project, you have to place tubes across continents or across countries. So what happens? What do people find when we place these kind of large infrastructure projects, and how can we get rid of the not in my backyard principle when implementing a full Hyperloop system? And on the technical side, then we have yeah, the conceptual feasibility study of the Hyperloop's vehicle thermal management system, aligned with also the technical department's goals of designing a heat battery. So what would happen to the heat dissipation in a Hyperloop system when you conceptualize this entire project instead of the pod that we only develop as a prototype? So how would the heat management system of a full-scale Hyperloop look like? Yeah, so along with this, we obviously have a lot of challenges still in Hyperloop. So both technical and non-technical. So the development of scalable systems. How can you scale these systems up, and how can you design systems that are scalable for future implementation? How can you develop the infrastructure that is needed for this project? How can you do this all in a very safe manner? And yeah, then on the non-technical side, we have the social acceptance of a Hyperloop. Then also the international regulations that come along with it. How can you make the Hyperloop also a cost-effective and competitive mode of transport in the current transportation system? How can you place this infrastructure across countries, and how can you do this all in a sustainable way? Yeah, so basically, also Dan is also here to maybe tell a bit more about the motor, because he's a propulsion engineer of our Hyperloop of our Hyperloop team. So yeah, just we want to keep this a bit interactive, and yeah, we'd love to hear from you guys if you have any questions. So thanks a lot.
Yeah, thank you, Delft, for your really informative and great presentation. So again, if you have any questions, you can ask them either by raising your hand or typing them in chat. Yeah, Kevin.
Yeah, I think I'll ask a question. Yeah, it was great to see you guys last year at UCW or this past summer, and really intrigued by the technical research aspect. So you mentioned a few topics of kind of problems that you face. So
Mhm.
how do you see the team tackle these problems in the future? Like, what will be the topics? What's the sequence, and what's the strategy to solve them?
Yeah, so if I understand your question correctly, like how do we choose which topics we want to research? Is that the correct way I'm understanding your question?
Yeah, and also like how
Yeah.
are you gonna solve them?
Yeah, so a lot comes along with it, like when we want to choose the topic of research, and for this we talk to our partners who are in the industry, so people in the chain of the Hyperloop, for example, a lot of different companies regarding with infrastructure, also Hyperloop companies, and we talk to people about how we want to yeah, what are the biggest challenges ahead basically, and then pick our research in that way. Regarding on solving them, yeah, on the technical side, of course, we try to implement some of the things that we find in our full scale research, also what is possible into our current Hyperloop prototype. So, for example, like we did with the thermal management system, yeah, the conclusion basically of the research is of the thermal research is to design a heat battery, and yeah, that's also what we did on the technical side in our prototype as well. So it's hand in hand with the full scale paper. That
Awesome,
answer.
thank you.
Yeah, no worries.
Yep, Sammy.
Yes, hi. So you mentioned scalability a lot of times in your presentation.
Mhm.
So first of all, what do you mean by it? How do you define it? How can you measure it as a team? Also, when you find a challenge of scalability, how do you measure it? How do you define it?
Yeah. Yeah, so yeah, what is scalability exactly? Yeah, scalability is the ability, we see scalability as the ability to transform our system that we design as a prototype to a full scale level. And that comes along with technical challenges, but also a lot of non-technical or not like technical, but really cost-effective design solutions, basically. So regarding the motor, it's designing a system that is actually implementable instead of just keeping it as a fantasy, let's say.
Thank you, Delft, again for presenting, and we hope to see you at our conference next year in Toronto. We have a last-minute question from Ardra.
Hello, am I audible?
Yes, we can hear you.
Yeah, I would like to ask your approach and view towards the non-technical report.
Yeah, so on the non-technical side, obviously a lot of challenges also arise there. And yeah, for this, as mentioned, basically the same as with the tech reports, we try to talk to people in industry. So this includes Hyperloop companies, but also, for example, in our case, the European Union or the Dutch government. Like what kind of challenges really arise, for example, on a socio-economic level. So the first couple of months, our approach is basically to really get a feel of what the problems are and interview a lot of people. And based on that, we choose our research topic.